and today we are here to start the lecture series of Mathematics-02. Chapter is Laplace Transform and lecture number 3, First Shifting Theorem. So today we will discuss about the first shifting theorem. In last two sessions we are discussed about the basic formula of the Laplace transform, definition of the Laplace transform and some application of the basic formula on the examples. Okay, so we start first shifting theorem. First of all, what is a first shifting theorem? First shifting theorem statement says that if Laplace of f of t equal to f of s, then Laplace of e raised to at f of t equal to f of s minus a. That means we say that if Laplace applying for the function f of t and we getting as an answer of the f of s, then if any function multiply with the e raised to at and after that you have to apply you are applying Laplace transform for that, then in the answer you get f of s minus a formation. Okay, so a proof of the first shifting theorem. If Laplace of f of t equal to 0 to infinite e raised to minus st f of t dt is a definition of Laplace transform. Okay. Now we are replacing this function with e raised to at f of t. E raised to at f of t, we are replacing this f of t with e raised to at f of t. Base are same, so we write as integration 0 to infinite e raised to minus s minus at f of t dt. Now if we are assuming s minus a equal to r, so we write as a 0 to infinite e raised to minus rt f of t dt. But this is the Laplace transform definition. What we say for the Laplace transform? Here r is a parameter, so we say that it is a f of r. But r is a s minus a, so we write as a f of s minus a. So this is a proof of the first shifting theorem. Example, find the Laplace transform of the e raised to 2t sin square 3t. Okay. Example, find Laplace transform of the e raised to 2t sin square 3t. First of all, Laplace of e raised to 2t sin square 3t. Okay. What is the original function? Original function say that if we are applying the like is a e raised to at and f of t, right? What is f of t? F of t is sin square 3t. So first step 1 is find Laplace of sin square 3t. We are applying trigonometry function Laplace of 1 minus cos 6t, angle is dual, because Laplace is not applicable for the square function. So we are applying this 1 by 2, Laplace of 1 is 1 by s, Laplace of cos 6t is s upon s square plus 36. This is the Laplace of the sin square 3t. Now, step 2. Apply Laplace e raised to 2t sin square 3t. Okay. 1 by 2, 1 by s minus s upon s square plus 36. What is the first shifting theorem? First shifting theorem says that where s tends to s minus a. What is a? A is a s minus a. A is a power of e raised to at. So what is a? A here is 2. So answer is 1 by 2 1 upon s minus 2, s minus 2, s minus 2 whole square plus 36 is the answer. We are replacing s to s minus a. So first shifting theorem replace a s tends to s minus a formation in a answer. So this is your last answer. After that we have to taking a LCM and solve this example further. Okay, but this is the actual procedure of the first shifting theorem. Next example, Laplace transform of t plus 1 whole square e raised to t. Okay. So Laplace of e raised to t plus 1 whole square. Step 1. Laplace of t plus 1 whole square. So it is Laplace of t square plus 2t plus 1. Okay. What is Laplace of t square plus 2t plus 1? It is 2 factorial upon s cube, 2 upon s square, because it's 1 factorial, it is 1 plus 1 by s. This is a Laplace transform of the t plus 1 whole square. Now we are applying step 2, first shifting theorem. What is first shifting theorem? E raised to t plus 1 whole square. What is your answer of the Laplace of t plus 1? This 2 factorial s cube plus 2 upon s square plus 1 by s. And we are replacing s tends to s minus 1 because here a equal to 1. Okay. So 2 factorial upon s minus 1 whole cube, 2 upon s minus 1 whole square plus 1 upon s minus 1 is the answer of this example. Clear? Next example. Find the Laplace transform of the e raised to minus 3t 2 cos 5t minus 3 sin 5t. First of all, Laplace of 2 cos 5t minus 3 sin 5t. Okay. This is our step 1. What is the Laplace of 2 cos 5t? 2 is constant. What is cos 5t? It is s square plus 25 minus 3 constant sin 5t. What is sin 5t Laplace? A upon s square plus a square. What is a? A is a 5. S square plus 25. Okay. So it is 2s upon s square plus 25 minus 3s. Sorry, 3 fifths are 15. So it is 15 upon s square plus 25. So answer is 2s minus 15 upon s square plus 25. This is the Laplace transform of the only this bracket. Now applying first shifting theorem. Laplace of e raised to minus 3t 2 cos 5t minus 3 sin 5t. Okay. What is your answer? Answer say that it is 2s minus 15 upon s square plus 25. Due to first shifting theorem, we are replacing s to s plus 3. Why? Because here a is a minus. In the formula, a is a plus. So, if formula say that e raised to 80 f of t and we are applying Laplace, answer is f of s minus a. If it is minus, then it is plus. Okay. So, due to this, here minus 3, we replace s tends plus 3. So answer is 2s plus 3 minus 15 upon s plus 3 whole square plus 25. Okay, so last answer is 2s plus 6 minus 15. So it is minus 9 upon s square plus 9s plus 9. Sorry, s square plus 6s plus 9 plus 25, that is 34. So this is your last answer of this example. Clear? So this is your first shifting theorem.